Hello guys, welcome to C programming from scratch to advanced. Hello guys, welcome to C programming from scratch to advanced, brought to you by Six Phrase MySlate. And I'm Sachin, a technical trainer here in Six Phrase MySlate. And in this lecture, what we will be seeing is that this is an extensive course. Using this course, you can start from a very basic point and we will be entering into advanced concept. And this C programming course will help you in learning data structure, to get into data structure and into algorithms in a very better position. Okay, so this is a very extensive course, specially structured for people who is beginning to learn any programming language. Okay, any beginner, for any beginner, this course is going to be really amazing one. Okay, so in this particular session, in this lecture, we'll be seeing how a computer works, and next we'll see how about something about number system. We'll see what is a program, and we'll see the difference between the low level and high level languages, and we will see the difference between a compiler and the interpreter, and also we will see what is a operating system. And now we'll just start this session by starting with how your computer works. Okay, so in this slide, I think it is clearly visible that you are shown with a block diagram, and this block diagram is showing the part of CPU as well as the hard disk here. And if you see here that you have right, so here there is a block diagram available, and this block diagram shows the inner part of the CPU as well as the connection between the CPU and the hard disk, the connection between the input and the CPU, and the output and CPU. And here if you see, there are several components like ALU, CU, main memory, input buffer, output buffer, hard disk drive. I'll be explaining you about each and every component, what is the usage of, what is the work of each and every component. And first of all, let me take ALU. Okay, arithmetic and logic unit. So in the arithmetic and logic unit of it, see, it does all the basic operation. For example, what are the basic operation that ALU does is that it does addition, it does subtraction, it does multiplication, it does division, and it also does mod operation also. About these operations we will be seeing in a separate video, but here let me just tell you that ALU is going to do this basic operation called the addition, subtraction, multiplication, division, and mod, as also, like for example, greater than, less than, and equal to, for example, and logical and as well as the bitwise and. Both are different usages there. Logical and bitwise and, same like logical OR and bitwise OR, and logical NOT operator will be there. And these are the very basic kind of operation that the arithmetic and logic unit will perform. So here in the block diagram, very first component is ALU, and this ALU will do the basic operation like addition, subtraction, multiplication, division, mod, greater than, less than, equal to. Logical and bitwise, logical and bitwise and, logical OR, bitwise OR, and logical NOT. Like this, several basic operation can be performed by using the ALU component. And the next component is CU, control unit. What is the usage of control unit? You have several other resources like input system, output system, hard disk, main memory, ALU. All these are called as the resources of the computer system, and all these resources of the computer systems are controlled by this control unit. All the resources, input, output, main memory, ALU, hard disk, all these resources are controlled by this control unit. And now next comes the main memory. What is a main memory? Main memory is a RAM memory. RAM, random access memory. What is the need for random access memory? What is the need for this main memory? What is the need for RAM? Actually, if you see here, this main memory RAM is a very small memory and a very speed memory. Why it is introduced is that here is a hard disk, which is a very vast memory. For example, if you see your own system hard disk, it is like 400 GB, it is like 500 GB, 1 TB, 2 TB. But if you see your system's RAM, if you go and check your system's RAM, for example, let me show you the RAM of my system. If you just go to your PC and right click on properties, it will show you what is the RAM installed, 8 GB. It's a very limited storage. Your hard disk is like 1 TB. Okay, if you see my hard disk, it is going to be like 1 TB here, approximately 1 TB. And if you see my RAM, my RAM is just 8 GB. So why this RAM is introduced is, hard disk is a slow memory. If I want to access any data inside my hard disk, then the accessal is very slow. Since the accessal is very slow, we introduce a very temporary memory called as RAM, which is a very fast memory. And so what we did is that all the programs that is in closed state will be there stored in hard disk. All the program that is in closed state will be there in the hard disk, and whenever you open a program, that program files will be copied here to the RAM, to the main memory, and then it will be executed here in the main memory only. For example, let me show you an example of it. For example, we have several software here, program files. We will see what is a program file later, but I'm using the terminology called program file. For example, there is something called as Firefox, which is a program file. Okay, so when I click on this program, now this program file is in closed state. You can see here in the taskbar also, no program file is open. Okay, no Firefox is open. Now I'm going to open the Firefox. So now the Firefox is in closed state, which is stored in the hard disk. Where is the hard disk? For example, if you see here in this, just I'll enter into the hard disk folder. In the hard disk folder, I have program files. In this program files, I have something called as Mozilla Firefox. Inside a Mozilla Firefox, if I see that I am having a Firefox, a file called Firefox. If you just click on the properties of it, it's showing that it is application.exe. So whichever programs or whichever files are .exe with .exe extension, those files are called as program files. I will tell you later why .exe files are called as program files, but generally .exe files are called as program files. So now you can see this program file is now in the, where it is in the hard disk. So when you click on this program file, now it is in closed state, so it is stored in hard disk. Now when you click on it, it will open. What is open? All these files which is in this folder are copied to the RAM, and once all the data is copied to the RAM, automatically what happens? Automatically the application is opened. The program file is in open state. If you can see here, that your Firefox is opened. Yes. So now when it is in closed state, it is in the hard disk. So you can see here, when a particular application is in closed state, it is in the hard disk, and when you try to open it, all the files that is related to the program file will be copied, will be transferred, will be brought here to the main memory, and it will be executed in the main memory. Now this entire window is now open because it is all the application codes are now in the RAM, and your program is in the execution state, because once your program files are copied to the main memory, your CPU will automatically execute it. Once you execute it, this program is now in open state. Okay, so from this what you understand is that you have a hard disk, you have a RAM. Both are different memory. Main memory is called as RAM. Hard disk is a slow memory, but it is large in size. But main memory RAM is a fast memory, but it is very limited in size. So when a program file is in closed state, it is stored in hard disk. When it is open, then these program files are transferred. It's transferred to main memory, and it is executed inside the main memory, where it is executed in the RAM. So whenever a program is in open state, whenever a program is in execution state, then it is in the RAM, it is not in the hard disk. Okay, fine. So now what is the input buffer? Input buffer is this green color is the input buffer. Why this is used? For example, you take a program file, you copy the program file, you brought the program file to the main memory, to the RAM, and now this is going to be in execution. Now your program Firefox is in execution state. Your program might require certain input. What is the input for your Firefox? For example, you can write a domain, google.com as a domain. You can enter google.com. When google.com is entered, what happens? This is the input that you give, and a certain output is displayed here. Am I right or wrong? So now what will happen is that whatever input is given through the input device, that input will be sent not directly to the application, it will be sent to the input buffer. This input buffer will be storing that input, and this application will be reading the input from the this input buffer. Okay. So when the program file is brought to the main memory, to the RAM, once it is in execution state, it might require certain input, as I showed you. So those input are not directly sent from the input device to the application. This input device will send the input to this input buffer, and this input buffer will storing those inputs temporarily, and our program which is in execution will receive the input through this buffer, not from the device directly. Similarly, whatever output you need to display, those output will be sent to the output buffer, and your output buffer will be storing it temporarily, and later your output device will receive the data from output buffer and it will be displaying it. Like for example, here it displayed this google.com page here in the web browser, right? This is one kind of displaying the output. Okay, fine. So now if you see here in the diagram, we know now what is the purpose of ALU, what is the purpose of CU, what is the usage of input, output and buffer also, and what is the usage of RAM, main memory, what is the usage of hard disk. Okay, fine. Now with this thing, what I need to tell you is that there are two kinds of file. I told you directly program files, but exactly when you see, there are two kinds of files available. There are two kinds of files. What are the files? One is program files. One is program files. What is the other thing? The other thing is, one is program file, the other one is data file. The other one is the data file. So what is the difference between a program file and a data file? For example, let me open a notepad. Okay, let me show you a notepad. So in this notepad, if you see, this notepad is actually a .exe file. So whenever something is .exe, I told you it is a program file. So notepad is a .exe file, and for example, what I do is that I type something inside. I type some data inside this, and I type some data inside it, and I'm going to save it. So while I'm saving, what is happening is that, for example, test.txt, I'm just saving a file called test.txt. Okay, now just let me go to the place where I saved it actually. So here I'm just I saved something called test.txt, right? This is saved here in test.txt. So if I open it, this file is opened. For example, this is a different file, but let us just tell this is a file, some file, that text file that we have saved. So this text file is a data file which is created by using the program file called notepad. So notepad is a program file, and the file that I create, a .txt file that I create using this program file, is called as a data file. So notepad.exe, okay, notepad.exe is a program file. Okay, notepad.exe is a program file, and test.txt is a data file. This is what the difference between a program file and data file. Okay, so which programs can be executed, which files can be executed? A program file only can be executed. A program file can be only directly sent for execution. A data file cannot be sent for execution. That we should remember always. Okay, fine. So now the next thing that what I will show you is that, let me go back again to the diagram. So I think you have a complete understanding about how the computer works. You know about what is the usage of ALU, what is the usage of control unit, main memory, what is main memory, why we introduce main memory, what is hard disk, what is files. We have two different files, program files and data file. We know the difference between both is, and if some file has to be taken from here to here, then it has to be definitely a .exe file, program file. Then program file only can be brought from hard disk to the main memory. And if I want to take data, if I want to take a data file from hard disk to main memory, then it can be brought by using through, it can be brought through a system file, using a program file. Where notepad is a program file and whatever written inside this is a data file. A data file, if it has to be brought to the main memory, then it can be brought through the program file called notepad only. It cannot independently come to the main memory. Okay, fine. So next one is input output buffer. You know why we require input buffer and why we require output buffer. They are temporary input output storing places. Okay, right. Next we will enter into something here. So if you see here, the entire computer system is an electronic device. So electronic device means, electronic device, everybody knows that electronic devices are controlled by using only voltages. For example, when you take a bulb can glow or it can stop glowing. If it glows means it is in on state. If it is not glowing, if it is stopping, then it is in off state. So either high voltage, if it is glowing means you are giving high voltage. If it is stopping, then it is having a low voltage. So either high voltage or low voltage. Using high voltage and low voltage only, every electronic device is working. So computer is also one of the electronic device. So it is also going to work on this voltage principle, either high voltage or low voltage, either on or off, either 1 or 0, which means a binary language. So computer, we say that computer knows only 1 and 0. Why? Because it is an electronic device and it uses a voltage principle. That is the one reason why computer understand only binary system, not any other languages. But when we come to human side, human understand the decimal number system better. What is a decimal number system? The usual number system that we are using. Decimal number system means 10 symbols are allowed. What is a decimal number system? A decimal number system means 10 symbols are allowed. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 symbols available. Okay. So when you create a number using any combination of this decimal, combination means you can take 1 and you can combine it with 0. It makes 10. You can take 1, combine it with the same 1 again. You can take 1, combine it with 2. But only the symbols allowed are 0 to 9. You can take any of these symbols and you can make any combination. Okay, the length can be anything. So that is what the decimal number system. We will see deep about number system, decimal number system later. But now just using these 10 symbols, if you're forming a number, then it is called as a decimal number system. So human understand those decimal number system only. But machine, we clearly said that it understand only either low voltage or high voltage. It means 0 or 1 only. So human understand decimal number system, machine understand binary number system. This difference we should understand. Next, so since I showed you the difference between the human understanding language as well as a machine understanding language, number system becomes a very major role, plays an important role in this. So we are seeing about number system. How many number system available? 4 kind of number system. Binary, already we saw that only 2 symbols allowed, 0 and 1. Coming to octal, 8 symbols from 0 to 7 will be available. Coming to decimal, 10 symbols from 0 to 9 will be available. Coming to hexadecimal, totally 16 symbols will be available from 0 to F, 0, 1, 2, 3, 4 and up to 9, and then 10 is represented by character called A, then B, C, D, E and F. And we say that base of binary is 2, base of octal is 8, base of decimal is 10, base of hexadecimal is 16. Why we call base? What is base? Base means number of symbols allowed. How many number of symbols allowed in binary? Only 2. That is why base is 2. Octal, totally 8 symbols are allowed, so base is 8. In decimal, totally 10 symbols are allowed, so decimal is having a base 10. Similarly for hexadecimal also. So we will not be seeing about the octal system and the hexadecimal system now, but we will see about binary and decimal, because we have already seen that human understandable code is decimal code and machine understandable code is binary code. So we will see the relationship between the binary and the decimal system. So this is a general table where I have shown the corresponding decimal, binary, octal, hexadecimal representation of few numbers. Okay, so this you can observe later. We will just get into binary as well as decimal, and we will see the connections between the decimal and as well as the binary language. See, here I have taken a number called 25, and in the bracket I am just giving 10. Why? What is the reason? Because 25 is possible in also octal as well as hexadecimal, because octal is also allowing 2 and 5, hexadecimal is also allowing 2 and 5. So this can be either of decimal or octal or hexadecimal. So in order to mention that this is of decimal, I'm mentioning the base 10. So 25 of base 10 has to be converted to base 2. How? I'm going to take this 25, the decimal number called 25, and I'm just keep on dividing it by 2. Why I'm keep on dividing it by 2? Because I want to have to convert it to the base called 2. If I want to convert it to the base called 2, I have to keep on dividing it by 2. So 25 is divided by 2. So this 25 is the divide, and 2 is the divisor, and 1 is the remainder. So just mark all these things. So dividend, I'm dividing it by 2, so I get the quotient called 12. Again, change this quotient into a dividend, again divide it by 2. You get a new quotient 6. Divide it again by 2. You get a quotient 3. So when you're dividing 25 by 2, you get the quotient 12, but you get the remainder 1. Mark it here. Then when you divide 12 by 2, you get the quotient 6, and there is no remainder, so remainder is 0. Divide your 6 by 2, you get the quotient 3, and no remainder, so remainder is 0. And next you divide 3 by 2, you get the quotient 1, and remainder is 1. So once your quotient becomes 1, stop the process. Start taking it from the reverse. Take this 1 as a first bit. The next is this 1 bit, 1, 0, 0, 1. So the corresponding binary representation of 25 is 1, 1, 0, 0, 1. So 1, 1, 0, 0, 1 of base 2. So this is how you convert a given decimal number to a binary number. Now I will show you the vice versa conversion from binary to decimal. If you want to convert the binary number to decimal, binary 11001 of base 2 to 25 a decimal of base 10, then what you need to do is that take each and every bit separately, 11001, and corresponding to every bit you write the base. Since this is of base 2, I am raising 2, the power place 0, so 2 base 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So now after writing these powers, now what you do is multiply the bit and the powers. So 1 into 2 power 4 add, plus 1 into 2 power 3 plus 0 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. That will give you the decimal answer. So 1 into 2 power 4 means 2 power 4 is 16. So 16 plus 1 into 2 power 3 is 18. 8. So 16 plus 8 is 24. Then 24 plus 0, 24, 24 plus again 0, 24, 24 plus 1 is 25. Why this is 0? Because anything multiplied by 0 will be 0. Anything multiplied by 0 will be 0. Here, anything power 0 will be 1. So 1 multiplied by 1 is 1. So 16, 8, 0, 0, 1. Adding all these things together, we get 25. This is how you convert a given binary number to a decimal number. Okay, so I have given you the method of how to convert a decimal to binary and how to vice versa convert binary to decimal. And these operations are done automatically in the background by the CPU. but even though we learn it to understand the working of CPU very better. Okay, fine. So now after seeing these conversions from binary to decimal and decimal to binary, now we will see what is a program, because in the first slide itself I told you something that only program files can be brought here to the main memory, but I did not tell you what is a program file. I told you the difference between program file and data file. A program file is .exe file and a data file is like .txt file, but still now we have not seen the clear explanation of what is a program file. So now we will see what is a program file. For example, see, why we require program is that to perform a calculation, to perform computational calculations. I think computational calculations can be performed by the calculator itself, you know, but why we require computer programs, we will see now. For example, let me open a calculator. For example, in the calculator, let me first of all take adding two numbers. What two numbers? I'm going to add 5 and 6. To add 5 and 6, what you will do, you will go to the calculator and first of all you will press 5 followed by the plus sign, because you need to add. So I'm entering the plus operator, then 6, then equal to. So this will show you the sum of two numbers. So it means that it is very clearly evident that this operation, adding, is an operation, and this operation, your calculator knows how to do this operation. Your calculator knows how to do the add operation. So you are adding two numbers. Calculator know how to add two numbers. So when you give the input, it is adding and it is displaying me the output. Now let me give you one more task. You need to find the average of numbers. For example, I will take few numbers called 10, 15, 8, 6, 9. Okay, it is 10, 15, 8, 6, 9, 5, 12, 13, 11, 16. For example, let me take these numbers. How many numbers we have taken so far? 3, 6, 9, 10 numbers. So if I want to find the average of these numbers, what we need to do? Go to a calculator, take a calculator, and this calculator, what you need to do is enter the numbers one by one. First of all, find the sum of the numbers. So first of all, I will enter 10, then followed by plus, then I will enter 15, followed by add, then I will add 8, then again plus, then 6, add 9, add 5, add 12, 13, 11 and 16. What's the total that you get? You get 105. If you want to find the average of these numbers, what you need to do? How many numbers you added? You added 10 numbers. So you have to divide this total sum by 10. You have to add these two numbers, add the total, you have to divide the total number by the number of elements you have added. So when you divide, you get 10.5. Can you understand one thing? When you perform add operation, this plus operator directly knows what to do, and our add operation calculator itself knows what to do, and it is doing the operation. But coming to average, the calculator does not know how to find average. We are giving instruction, adding all the other numbers, then finally dividing it all the numbers by 10. So add is a single operation, but average is not a single operation. Average is taking adding several numbers, as well as division is also taking place. So add is a single operation, but whereas add is a single operation, but whereas average is not a single operation, it is a multiple operation. When multiple operation is taking place, then I can call that as a procedure. So average is a procedure, it is not a single operation. but add is a single operation. When it is single operation, then calculator will comfortably do it. But when it is coming to the average, when it is coming to procedure, then it does not know procedure. Then the human who is using the calculator knows the procedure, and we are following the procedure to get the average, but calculator is not giving the average by default, like adding two numbers. So when a procedure need to be done, then calculator cannot be used. Then I need to come to a computer system. So in the computer system, what you're doing is that you are writing lines of instruction. You're writing lines of instruction, and those lines of instruction are saved as a file. What this file will do, this file is having a collection of instructions, and these instructions together perform a particular procedure. When a particular file is written for executing, is written for doing a particular procedure, then that file is called as a program file. So what you do, you write a collection of instruction. Why you write a collection of instruction? To perform a procedure, and this collection of instruction is saved as a file, and this file is called as a program file. So a program file can be also called as a program file is a collection of related instruction that together perform a certain procedure. Okay, so whenever you want to perform a procedure, so write instruction, save those instructions as a separate file, and that file becomes a program file. Hope you understand what is a program actually, right? So now let me show you some other thing. Now the same number I have taken, these are the numbers which I have taken to find the average. And now if you see, this is data, and I told you I have to find average. If you want to find average, you will write certain instruction to find average. So data is there and certain instructions are there. That instruction will be performed upon the data. You have certain instruction, for example, what are the instructions that will find average? Those instructions will be carried out, that will be carried out upon the data. Now if you see what is a form of data and what is a form of instruction, the data will be English. For example, these numbers are English numbers, called as generally termed as English numbers. So let me take that it is in the language called English, and also the instructions also there in English only. So when the data is in English, instruction is in English, these instruction has to be executed by the computer. These instructions has to be executed by the computer. But computer knows only binary language. We already saw computer only knows machine language. Since computer knows only machine language, it cannot directly take your data and instruction which is in the English language. So generally this language is called as natural language. The human understandable language is called as natural language, and the CPU understanding language, computer understanding language, is called as machine language. Since this is not a machine language, this is a natural language, this cannot directly be taken by the CPU and executed. Now what to do? We have two options. Either CPU have to learn the language of humans, or human have to learn the language of machine. Both are difficult tasks. Since both are a difficult task, we introduced a new language called programming language, which can be understood by the computer also, as well as it can be understood by the human also. Okay, so what is this So we introduced something called as programming language.